afternoon to everyone who is here in this virtual teleconference. And yeah, that's correct. No, a bit of information for myself. I hope I'm clear. Naririnig ba ako ng lahat?
Yes, clear po.
Okay, thank you. So, yes, that's correct. I'm actually Kohai, o kaya in our language, a junior of Dr. Renan during our PhD days in Kochi University. And I'm from the south, and he's from the north. So, I'm to proceed with my presentation. Wait a minute. Here we go. Ayan na. Ganit pa lang. Wait lang ha. Okay. Yeah. So, okay, can you see my screen? Let me...
Yes. Malinaw, Dokali.
Okay, so my presentation is actually already a detailed study with my colleagues in this research, namely Kentaro Honda, Wilfredo H. Uy, Darwin Baslov, Yuri Nakamura, and Masahiro Nakauka. So this is actually under the second project, which is the Coastal Ecosystem Conservation and Adaptive Management. And so this is a collaborative research from Hokkaido University, Mindanao State University at Naawan, and MSU Nawan Foundation at Kochi University. So the topic that I am going to share to everyone to you this afternoon is about the habitat risk patterns of commercially important fishes using acoustic telemetry. And this is a tool for designing marine protected areas in the Philippines. So let's begin with the background why we do this study. According to the study of Honda et al. In 2013, they found out interconnectivity of organisms among different habitats, especially for the fish. So we found out that some fish shift their habitats from either mangrove or seagrass habitats to coral reef as they grow. And this is what we define as the ontogenetic habitat shift. So once they grow, they shift from one habitat to another. So some, as you can see in the figure, there are a lot of fishes that can be found in mangroves, and then some in seagrass, and then also some in Oviplama. So this indicates some shifts among these habitats. And like for example, Litrinus harak, one commercially important fish, really prove an ontogenetic habitat shift from mangrove and seagrass habitats to coral reefs. So, and this is from our fish visual census, and adult-sized fish were observed also in seagrass beds. So, but since our survey is more on ocular survey, we really need to prove if they really use this kind of multiple habitats and migrate from different habitats from time to time. And in order to clarify this, we used a acoustic telemetry study for about a year, from 2011 to 2012. So this year is actually its anniversary. So objective of this study is first thing to clarify commercial fish migratory patterns, its range and habitat use. This the essence of habitat use, and the goal for this objective is to use for adaptive management of coastal ecosystem, particularly in determining the suitable size of MPA and its component habitat structures, because some of the Philippine MPAs are complete habitat compositions or components. So we have coral reef seagrass bed and mangroves, but there are also some protected areas that only coral reefs or seagrass beds or only coral reefs itself. So is there really important to include all these coastal ecosystems or not? Is one way of answering also to this study. So, as for the materials and methods, what is passive acoustic telemetry? So, as layman term, it's actually a method to study fish migration and habitat use. So, if you want to know where the fish moves or where the fish goes, so this is a good instrument for you or a tool for us to track fishes. So, what happens is that the fish is with an acoustic transmitter, and this transmitter is inserted in the peri- peritoneal cavity of the fish. So it's the space of the fish inside the stomach where it can fit. And once it is inserted in the stomach of the fish, we have also one instrument which we call as the receiver. And once the fish is within the zone of the receiver, uh, the transmitter inside its stomach is being detected by this receiver. And the size of the receiver depends also the battery life. So the bigger the receiver is, the bigger also its battery life. So it could, the smaller one has a 2 months battery life, and the larger one also has a year of lifespan for the battery. So this means to say that uh, if we want to record for a longer period of time, we need to catch a larger fish to accommodate the larger transmitter. Because a smaller fish, and we can still insert the bigger one, but the buoyancy is the buoyancy of the fish in swimming is affected. So there's a need for us to catch a bigger one. So the one challenge sa ganitong study is the capturing the fish alive, because how can you detect the movement of fish if you collect a dead fish? So you need to catch it alive and be sure to, after catching it alive, you have to acclimatize it and be sure to that the fish will survive for longer periods of time after the operation and inserting of the transmitter. So to continue, our area or the study site that we did for this observation is Laguindingan, and with the coordination of the LGU, we got a permission to conduct this study inside the MPA. And the MPA of Laguindingan Municipality is a no-take MPA, and we since the acoustic telemetry has two instruments, the first one is the receiver and the other one is the transmitter. So for the receivers, we put four receivers in the coral reef area, and we put five receivers in the seagrass bed area. We were not able to put receivers in the mangrove because during lowest tide fluctuations in the tidal range in the Philippines, the area is quite inundated. So, hindi siya pwede malagyan ng receiver. So, walang deep areas din sa mangrove where we could install the receiver, which could still be submerged for at least 1 meter. But we could find some in the serious beds area, so this is one of the limitations also of our study. So the size also of the MPA is about 22 hectares. So this is almost the same average size of MPA in the Philippines. So the distance from one receiver to another is about, in the coral reef area, is about 150 to 300 meters. And from in the receivers that were uh, installed in the Seagrass area is about 60 to 150 meters. So this is to ensure the detection of the fish with the transmitter. Okay, so for the target fish, we need to um, target commercially important fish. So we targeted with genus Argentina pilatus. So I'm not sure if it's also the same local term in your area. This is what we call here the Maya Maya. Actually, Maya Maya has a lot of varieties known. So it could be all the genus could be called as Maya Maya. So we have two species for Luchanus, Luchanus argentinoculatus and Luchanus monastica. And we also have three species for Lichenus, Lichenus alap, Lichenus atkinsoni, and Lichenus absolutus. And one species for uh, Seganus family, which is the Seganus vittatus. And then so it's really quite hard to catch this fish alive. So we used a lot of methods, the catching methods. So we use the fish trap, yung tinatawag nilang bubo, which is actually bawal na ngayon. Actually, during the time that we fish, it's actually prohibited. But we managed to really get approval from the local government just for the research purposes. And we made sure that the fish we caught is alive and we will not kill it for consumption. Another to ensure as a backup for the fish trap, we use the long line and the hook and line. So all fishing activities were conducted inside the MPA or along the edge. So there was actually an issue during our research because there are local fishermen who are also jealous during our survey. But due to constant public we were able to convince them the purpose of our study. So with our study, we started from February 2011 to May 2012, and these are the following um, number of catches that we had for each species and then the sizes. So most of the fish that we caught are quite big, enough for us to insert the large size of the transmitter. And some are small, which is good for monitoring for 2 months only. So in total, we have 30 fish caught, and these were also acoustically tagged and released inside the aquarium. So this is how we attach the transmitter in the fish which we caught alive. So since the fish is alive, we need to put some anesthesia to make it stable. And once it's already in stable state, we put, of course, the anesthesia is hinalo po siya sa isang tank. Hindi naman tank, parang isa siyang yung mga box ng yung mga mega box, yung gano'n, na pwede siyang mailagay sa boat kasi we operated this inside the boat. So we mix the anesthesia in the box with the seawater, and then we let the fish swim until it floats and becomes stable. After that, we cut the stomach, and the cut is just parang ano lang siya sa pinakamaliit na kamay mo. Anong tawag doon? Yung finger, little finger. Enough for the little finger to insert in the cut. And then after that, we inserted the transmitter into its cavity and then stitch it out. And after stitching, we also put a dart cap on its back, and we measured the body size and the weight. After that, we then confirm its recovery inside the MPA with a net before also releasing it finally to the open water. So the time that we did this is very fast. Like we need to, the stitching must be done for as fast as 2 minutes. So we don't need the fish to be so stressed out, because if it's stressed out, we successfully tag the fish, but afterwards, because it's so stressed, we have some casualty. So we avoid that after our first casualty, because the fish we caught is inside the FAA. So that's the challenge. So then detection of data. So the detection of data in the data analysis, we consider the 1 day after the release. Uh, um, we omit it, so we don't consider it after releasing. So and then after that, the detection of data were divided into 4 categories. So uh, we divided them according to the outside corals. So this is C1 and C4 receivers, and then the inside coral reefs, the inside. So since we put the transmitter in wide range, so there are sorry, not transmitter but receivers. So there are receivers that are inside the MPA, and there are also receivers that are outside the MPA. So this is to gauge us if some of the fishes really swim inside or also go outside the MPA. So to estimate the residence times at each habitat, so periods without detection within 3 hours were shared half and half between the habitat of detection before and the habitat of detection after the no detection period. So there we really had quite a lot of data processing after difficulties in the field. And another is if fish had no detection period longer than 3 hours, so the exceeding period was excluded from all the categories and was defined as the missing period between. So, meaning to say po, uh, para malaman namin na residence time niya, meaning to say, yung residence time, quote unquote, will indicate us that this fish really use this habitat for during this time of the day or during this time of the night. So we have to have the conclusion, we have to make at least 3 hours na observe siya, na doon talaga siya na-detect. And then if there's no detection for 3 hours, so we put that as a missing period. Okay, so this is the result. So out from the 30 fishes that we caught and tagged, we found out that all of the fish were often detected inside the MPA. So that's about 95.4% of the total detections. And interestingly, as you can see, in the we have 6 species of fish, right? So for Luciana species, you can see that we can there's a lot of detections we can find with these fishes in the coral reef area. While for Lutrinus hara, we find that we could also detect these fishes, large detection in the seagrass area. And also another result that you can find in this figure, this green, is that um, all were detected in both coral reefs and seagrass area except for one species, which is Lutrinus atkinsoni. So as you can see, this one species of Lutrinus were only detected in the coral reef, and they were not detected in the seagrass habitat. So this means to say that this fish only um, use the coral reef area. The rest use both the seagrass beds and also the coral reefs. And this is quite uh, how to say, this is also the same from the previous graph, but this is more on the last graph is more on mapping where we detected it, but this is also the percentage of detection. So and this detection is we compared it if it's inside the MPA or outside the MPA. So if you can see this kind of graph, there are some sample of one species that we collected, like for example, for Litrinus harak, we found out that one or two, no, the three species uh, had some detection outside the seagrass bed receiver. And but aside from that, the message that we could get from this is that the smaller fishes were more often detected in the seagrass bed, especially for the Lucianus species. And detections were mostly recognized for Lucianus monostigma, Litvinus atkinsoni, and Litvinus occulus. And for the detection in both coral reefs, we have Lucianus argentimaculatus, Litvinus carac, and Siganus guttatus. So another is that uh, this graph shows the um, movement of the fish from one habitat to another. So from the graph, um, two-thirds of Litvinus harap and Siganus guttatus move more than once between the coral and the seagrass habitats. And this indicates that these two species really use these two habitats. And 22 individuals among the 6 species move one or more between inside and outside the FTA. And 11 individuals move between inside and outside MPA more than once per day on average. So in a day, we have out from the 30 individuals that we have 11 individuals that really move from inside to outside the MPA. Okay. And okay, this one is very interesting. Why? Because these are the detections of fish in a deal or from morning to evening. So daytime to nighttime. And in the coral reefs, uh, Lutrinos argentimaculatus are detected in the coral reefs day and night. And they are only detected in the seagrass beds at nighttime. So this is for Lucianus argentimaculatus. Now for the seagrass beds, you can see that L. Lutrinus harap, LEHA is what it means. So they are detected more on at nighttime in the coral reefs and at seagrass more on day. So kabaliktaran po, hindi naman kabaliktaran, pero yung Litrinus harap po natin, they are detected at night in the coral reefs and they are detected in the seagrass beds on daytime. For the Siganus guttatus naman, they are detected on daytime at the coral reefs, while they are detected in the seagrass beds more on nighttime. So, kabaliktaran po ng Litrinus harap. So, yung Litrinus harap natin, pumupunta siya sa seagrass on daily basis and at nighttime, pumupunta siya sa coral reefs. While ang Siganus natin, on daytime, nandun siya sa coral reefs, while at nighttime, dun siya sa seagrass beds. So, for the discussion and conclusion, we found out that not only juveniles but also some adult commercial fish occurred in seagrass beds, and this was also reported on some study of Nakamura and Kitsuya in 2008 and Liu et al. 2009. And we also concluded that the current NPA size in Lagutingan is probably wide enough for Litvinus harap, but not for others. In addition to species-specific daily migratory patterns, as such case for Lucianus argentimaculatus, Litvinus harap, and Siganus guttatus, there's a variability on the habitat use per individual, and the use of the NPA were observed in consistencies. So, with this, for some commercial fish species, NPA should include both seagrass and mangrove habitats as their nursery or feeding ground. Even though we don't include mangroves in our coastal development study, we support this through our similar research also or paper which the same authors had conducted for a member of the study. And the vertical migratory patterns near the offshore edge of the NPA also should be reviewed because some fish showed long missing periods of time. And this was also conducted and published in year 2017 by the same authors. So, in the last conclusion that we have, because we found out that there's a lot of missing periods of our tagged or collected fish, so we assume or we hypothesize that they might be doing the vertical pattern, migratory pattern, because the structure of the Philippine MPA is it's like a cliff, so and it's quite deep. So we hypothesize that during this missing period, they might do a vertical migratory uh, patterns of movement. So yes, so challenges. No live fish, no result for acoustic telemetry study. So catching live target fish for this study was difficult, even with the different methods we used. So in a day, with so many expenses, we sometimes get no fish, and it's a glory for us if we catch just one fish in a day. So no take MPA. We were allowed to fish inside since we do it for research purpose only. However, unavoidable issues with the local fisher folks may occur. So this is one, but we were so much grateful for over the time we were able to finish this with some good results. So I guess that's all. This is the theme of the study. This is quite a very fruitful one, and I hope I shared some information to everyone in our study. So this was me from 10 years ago. Okay, thank you, Sir Nan.
Okay, thank you very much, Docalyn, for presenting your past study about fish. So, any question from the class?
So
Yes.
pwede po mag-Tagalog
Yes, Brian, Mr. Navera, raise your hand.
Yes po, sir. Good afternoon po, ma'am.
Yes, good afternoon.
I'm just curious po on what happens po on the inserted device po after it has served its purpose po. Is it naturally excreted po sa body po ng fish, or is it okay po na it is left on the body of the fish because it has no harm po naman po na ma-inflict po dun sa fish?
Actually, the transmitter we use is disposable. Once we inserted it to the fish, there's no hope to get it back because the chances of catching the fish again is zero probability. So, ang nangyayari po niyan, hindi naman siya detrimental on the fish. It's just like it's an added baggage lang sa kanya. So that's why we need bigger fish in order for us to insert a quite enough size of transmitter na hindi naman masyadong nakakapag-explore on its physiological aspects and mobility. So, pag minsan merong nakahuli ng mga target fish namin, kasi pinapunta naman outside ng ibang fish. So, there was one report na nahuli daw nila na luto mayroong transmitter sa dyan. I don't know if it was true kasi wala naman nagpakita na evidence at a picture, but it could be possible that our tag fish were caught, but andun pa rin sa sa tiyan niya yung transmitter. That's why we need bigger fish kasi yung para maka-insert kami ng bigger transmitter in order for us to track the fish for a year as long as it's not also caught by other fishermen. Sige, meron pang
Okay.
gusto magtanong?
So, may tanong pa?
Meron bang gusto magtanong magkano yung transmitter? Actually, yung transmitter mahal. So, the smaller one, which is about, yung pinakamalaki is yung little finger mic. It costs around almost 80,000. So, that can track for a year. So, yun, 80,000 disposable lang po yun. But it could give you a good track of fish for a year. The two months transmitter is about 20 to 30,000. So, yeah, it's quite an expensive research, but it will give you a good solid data. Tapos yung receiver naman niya, yun yung pinakamahal. It's about $1 million na ano. So, but if you, Sir Nan, if you're interested with the study, we can partner with Lamago.
Yes.
They have receivers. They have
Pero
receivers.
they are more on focus on mammals.
Yes, large marine vertebrates.
Yeah.
But we can do that with Ulang. We could also do that with some commercial fish. It depends on our proposal.
Actually, one of my friends before sa WWF, they work on whale shark. Pero yung tag nila ay sa labas, hindi siya invasive. Doon
Iba
lang
naman
nakalagay
yun.
sa fin. Pero,
Parang,
but it detects migration pattern.
it's another, ano naman siya, it's another acoustic telemetry method. Yung sa amin is passive acoustic telemetry. So, we really need to do some harm
Doon po kayo sa kwarto
sa
ko.
fish.
Meron din.
But so far, kaya ang kinukuha namin malalaki para hindi siya harmful. Though the cut is not really that deep, just enough for the transmitter to be inserted on the cavity ng space lang siya. But interestingly, the study we found like yung sigas na, okay, so nighttime lang pala siya doon sa sigas and during the daytime, andun siya sa coral reefs. So, yun yung pattern niya. Yung namang harak, nakikita naman siya in the morning sa sigas beds, sa gabi doon siya sa coral reefs. So, kabalik na rin sa sigas.
So, itong acoustic telemetry study is more precise when it comes to the migration pattern or movement. It can also tell about the habitat shift kasi gumagalaw sila. But when it comes to the ontogenetic habitat shift, so isotope analysis can also be used for studying ontogenetic habitat shift by looking at the muscle, like
Components.
yes, yung isotopic signature ng
Yes.
juvenile, yung adult, kung ano yung signature sa muscle.
Ng carbon, tsaka it's also quite expensive research.
Yes, but relatively cheaper compared to acoustic telemetry.
Acoustic telemetry.
But,
Yeah,
but
true.
not that conclusive compared to acoustic telemetry, which is real-time yung result.
Result. Yes. Ang challenge lang nito po is paano mo po makuha yung isda na kamay.
Oh, yes.
Oo. And you really need to do a lot of prayer and na sana ngayong araw na to may makuha kami kahit isa.
Okay, so any more questions?
Yeah, more questions?
I think wala na. So, siguro may gagawin ka pa, Dokalin. Thank you very much
Yes.
for your time.
Thank you also for having me. Looking forward for more collaborations such as this. Hindi natuloy yung last year, baka matuloy naman this time, Chong, yung invitation ko.
Okay. Sige.
Message lang kita.
Okay, kasi. Thank you.
So, thank you everyone.
Okay. So, sige.
I will leave na po, Chong.
Okay, sige. Thank you.
Thank you.
Okay. The last na presentation